In this course, we will analyze the time series of the prices of an asset, assuming that it is a realization of the discrete time stochastic process. We have here the time series of IBM daily closing prices. We're monitoring the series as the sequence of discrete times T0, T1, T2, up to T capital N. Usually these times are equally spaced. For instance, the grid of times can be generated using this formula, with n being an integer equal to 0, 1, 2, up to capital N, and delta t could be, for instance, a day. The sequence of values of the time series will be labeled with the same index as the corresponding times, S0, S1, S2, up to S capital N. This time series could be truly a discrete process, or it could be the discrete monitoring of a continuous process. So if we have a continuous time process, we would evaluate the process S of t at the monitoring times Tn, and then we'll denote that value as Sn. We'll be interested in the statistical properties of this quantity. We can compute the mean of the process, so the mean of the time series at time Tn is denoted as the expected value of S sub n, and that is the mean. We'll also be interested in computing the variance of the series, and the variance is just the expected value of the square root of the time series, provided that we have subtracted the mean. This is the variance. If we're interested in analyzing the time structure of the time series, we'll be also interested in autocovariances. The autocovariances involve the values of the time series at two different instants in time, m and m plus n. And these are the autocovariances. The time series of IBM prices is not stationary. The mean, the variance, and the autocovariances change with time. It is generally simpler to work with stationary time series. A stationary time series has the following properties. A time series is said to be stationary if it looks similar in a statistical sense at all times. Here we have an example of a stationary time series. The series is monitored at discrete times T0, T1, T2, Tn, and the corresponding values are x0, x1, x2, xn. We're now going to define the conditions for weak stationarity. A time series is said to be weakly stationary if the expected value of the series at time n is independent of n, so it's equal to mu, where mu is a constant. The variance also has to be constant. And finally, the condition for the autocovariances. The autocovariances are such that they only depend on n, the delay between the two times involved in the calculation of the autocovariances.